Today we're going to talk about everything linear. So we'll talk about lines, how to find slopes, how to find equations of lines, parallel and perpendicular lines, etc. So first, a refresher on what is the formula for slope. We learned slope as rise over run. The formula is going to be y2 minus y1 over x2 minus x1. We have several options. If a line goes up to the right, we would say it has a positive slope. If it goes down to the right, a negative slope. Any line that is horizontal is a slope of 0. So in other words, the rise is going to be 0. So we would get 0 over some number. And lastly, a vertical line has an undefined slope because it doesn't have any run. If we have a horizontal line, the equation for that is going to be y equals, so it'll be y equals whatever the y value is or the y-intercept. Likewise, if we have a vertical line, it's going to be x equals. So horizontal and vertical lines will only have one variable. Horizontal will just be a y value. Vertical will be an x value. We're going to predominantly look at a different form of the line, but we'll review three forms of linear equations. So the first one is probably the second one that we learned. It's the general form of a line, and that is ax plus by equals c. The second form, and the one that most people use most often, is the slope-intercept form of a line. This is the one that tells us the slope and the y-intercept. And it is y equals mx plus b, where m is the slope and b is the y-intercept. And the third form, which we typically use more often in classes like calculus, will be point-slope form. And this one is y minus y1 equals m times x minus x1. So a little derivation of where that comes from. If we start with the formula for slope, we get m equals y minus y1 over x minus x1. And if we were to multiply both sides by the denominator, x minus x1, we end up with y minus y1 equals m times x minus x1. So the point-slope form is just the formula for slope in a slightly different form. A couple more things about general form. So ax plus by equals c. If we solve that for y, we get a general definition for how to find slope and y-intercept in that form. So we'll subtract ax from both sides, divide both sides by b, and we're done. We look at that and we say, well, the slope is the number in front of the x, so that's going to be negative a over b. So in general form, the slope is going to be negative a over b. And then that last number, c over b, is going to be my y-intercept. So if an equation is in general form, we can just read the slope and y-intercept from the equation. We don't have to solve for y. So parallel lines, we know most people would define those as lines that don't ever touch or cross. Algebraically, we would say that they have the same slopes. So two lines are going to be parallel if and only if they have the same slopes. Furthermore, we'll say that they have different y-intercepts. Otherwise, they would be what are called coincident lines, or the same line. So they have equal slopes but different y-intercepts. Perpendicular lines, those are lines that meet at a 90-degree angle. The relationship of their slopes is that the product of the two slopes is going to equal -1. Another way to think about that is to say that their slopes are negative reciprocals. And then lastly, let's look at an example. So here we're asked to find an equation that is parallel to y equals 15x, and it contains the point 7, negative 1. So the first thing we always need when we try to find an equation for a line is to find the slope. I know if I look at the original equation, y equals 15x, that the slope there is 15. Since I'm finding an equation that's parallel, I need a slope of 15. Now I'm going to use as an example the point-slope form which we just learned. So we'll substitute those values in. We get y minus negative 1 or y plus 1 equals 15, my slope, times x minus x1, which is 7. Now many times you're going to be asked to still write it in slope-intercept form, so we will solve for y. So we'll subtract the 1 from both sides, distribute on the right, we get 15x minus 105, and then we'll subtract the 1. When we simplify that, we end up with y equals 15x minus 106.